Alright, so we're going to use logarithmic differentiation to find the derivative of this extremely ugly function. So if you look at it and think to yourself, oh my god, this looks awful, I would never want to find the derivative of such a thing, quotient rule, chain rule, product rule, everything, then logarithmic differentiation is perfect for that type of problem. It can really be used on every problem, but a lot of times using our straightforward derivative rules is much simpler. So you sort of have to weigh your options. And so in this case, there are definitely a lot of different rules that would have to happen very carefully, and I'm not confident that I could do it without making a mistake. So logarithmic differentiation is a much better bet. So the process of logarithmic differentiation I outlined in the PowerPoint. It had a few steps to it. And the first is to take the natural log of both sides. So I'm going to take the natural log of the function f of x, and I'm just going to use the notation to show that I've done that. And I'm going to take the natural log of everything in my original function on the other side. So the natural log of x cubed minus 1 to the 4th times the square root of 3x minus 1, all divided by x squared plus 4. So that first step, there's really nothing going on. We're just showing that we're taking the natural log of both sides, which is perfectly legal as long as we do it to both sides of an equation. And the reason that it's helpful is because what I can then do, on the right side anyway, is I can use those log properties to take this product and quotient and rewrite it in separate sum and different terms. So I'm basically taking things that are being multiplied and divided, which are hard to take the derivative of, and separating them into added and subtracted terms, which are much easier to take the derivative of. Okay, so in order to use the rules of logarithmic properties, I am going to take these two pieces that are multiplied by each other, and I'm going to write them as the sum of each of the natural log of each. Okay, so anytime two terms and an argument of a log are being multiplied, you can write them as separate terms being added. And then this one here on the bottom is being divided, so I'll show that with a subtraction. Alright, so I can continue to use some log properties here to make this even easier. And one of those log properties says that if I have a power, my argument is raised to a power, I can write that power in front as a factor. And so I haven't taken a derivative there. Don't confuse it with the power rule. For derivatives, I'm just using the log property, allowing me to take the power in the front and write it as a coefficient. Now this one can have the same, we can employ the same rule there. Just think about the power as being 1/2. So you can think about it as 1/2 the natural log of 3x minus 1. And then over here we have minus the natural log of x squared plus 4. No power there, nothing to do. Alright, so we've taken this very complicated product, quotient, all of these things going on in this equation, and we've written it as the sum and difference of three separate terms. And so now we're going to actually find the derivative, and it's going to be much easier derivative to take. So step 3 is to take the derivative of both sides. Don't forget about the left side here. We do need to take the derivative of the natural log of f of x. So earlier in this PowerPoint, we talked about the rule, the definition of taking the derivative of a log, and it's 1 over the argument, in this case the argument being the function f of x. The chain rule applies here. I now need to take the derivative of that argument. Okay, so the derivative of the natural log of f of x is 1 over f of x times the derivative f prime of x. On the other side, I'm going to take a bunch of derivatives as well. I'm going to take the derivative of 3 separate terms. They all have natural logs in them, so I'm going to use that same natural log rule each time. In the first term, there's a 4 multiplier out in front, so the constant multiple rule says I can just leave it alone. and find the derivative of the rest of it. So the rest of it is 1 over the argument, 1 over x cubed minus 1, times the derivative of that argument, 3x squared. Okay, so that's my derivative of this first term. Let's take the derivative of the second term. Once again, the 1/2 can just kind of hang out, and then the derivative of a natural log is 1 over the argument times the derivative of the argument. And then finally here we have 1 over the argument times the derivative of the argument. So those individual terms are a lot easier to take the derivative of than had I needed to, I'm sorry, I'm stumbling over my words here, had I left this alone and not used logarithmic differentiation. So we didn't have to use any power rules. We didn't have to use, well, I guess we had to use a little bit of a power rule, but we didn't have to use product rule or quotient rule, which tend to make things really complicated. Taking the derivative of a natural log is fairly simple. We had a little bit of a chain rule to use each time, but not so bad. Okay, so step number 4 is to now solve for the derivative. So the derivative here, f prime of x, is located right here in our work. So I just need to isolate that. And so in order to isolate that, I need to multiply by the reciprocal, which is f of x. And so if I do that on the left side, I'm just going to isolate f prime, and then on the right side I'll have f of x multiplied by all of this stuff that we found up here. So as I copy it down, I might as well go ahead and clean it up a little bit. In this first term, I can multiply the 4 times the 3x squared. In the second term, I can multiply the 3 times the 1/2. And there, you may also want to just multiply through in these fractions, the 3 on the top, and then a 6x minus 2 on the bottom. In the last one, 2x on the top, x squared plus 4 on the bottom. Very last step, let's get rid of f of x. And how we get rid of it is just by replacing the original function, which is x cubed minus 1 to the 4th times the square root of 3x minus 1 over x squared plus 4. And then it's just going to be multiplied by all of these things. So I'll just copy everything. I think in this second term I'll go ahead and distribute. Okay, and I know it looks ugly, but this is the answer that they're looking for. This is what we want. Okay, we want to see the f of x, which is right here, the original equation, and then we want to see the derivative of each part when it was separated using the log properties. So in the end, the answer is much uglier, but the process is a heck of a lot easier than it would have been if we had stuck with our product and quotient rules here with all of the chain rules involved as well, at least in my opinion. So you can use logarithmic differentiation anytime, but it's nice to sort of save it for really complicated derivatives, and you get some really ugly answers. So in your homework, you should see problems that specifically say to use logarithmic differentiation in order to find derivatives. And on an exam, I would expect the same. I would expect to tell you when I would like you to show me that you know how to do the logarithmic differentiation. And then any other time, you can decide whether it's a better route than to just take the straightforward derivative.